Hello again, and this video is on Argand diagrams. Excellent. Okay, so let's look at the number system. So far we've looked at the number system here. We've had 0 here, 1, 2, etc. And we've got our negative numbers, -1, -2, -3, etc. And you have your half in here, and you have 3/2 there, and you've got all your irrational numbers and everything like that, and that was all fine. And what happened then is that when complex numbers were introduced, and we had this concept of the square root of -1, that's -7. When we had the square root of -1, where does that fit on this number line? And mathematicians argued about this for a long time. And a mathematician came up with the idea is that, well, maybe complex numbers can be thought of two-dimensional numbers, and they're not just one-dimensional. They don't just lie along this line, and in fact they lie along, oops, not a very good line there, they lie in a plane. And so complex numbers are actually two-dimensional. And so what you've got here is the square root of -1, and then you've got 2 times the square root of -1, etc. -1 lots of the square root of -1, etc. And so you've got a two-dimensional plane. And this was named after the man who invented it, and it's called an Argand diagram. And when we can represent things on this Argand diagram. So where is 1 plus the square root of -1? Well, you look at the real part, which is 1. You look at the imaginary part, which is the square root of -1, and so that number there would live on that point there. So that's right there. This became the way of representing complex numbers on a diagram. So let me just clear that up and have a bit of a go. If I was good, then I would have some sort of straight line tool. I should do it on a little bit messy, but you'll get the idea. And so an Argand diagram has two axes, and one is the real axis and the other is the imaginary axis. So let's just have a look at this. This should be quite simple once you get the idea. And so we've got two axes. What's this axis? We're going to call it the real part of Z. Okay, the real part of our imaginary number Z, and here is our imaginary part of Z. So we label those two axes like that. And then we have 1, 2, 3, 4, etc. -1, -2, -3, -4. 1, 2, 3. Okay. -1, -2, -3. So let's look at a few examples. Let's have Z1. Let's have 1 plus 2i. Let Z2 be -2 minus i. Z3 be root 3 minus 2i. That'll be enough to give an example. Okay, so let's have a look. Where does Z1 live on this plane, this Argand diagram? Well, its real part is 1. Okay, so real part is 1. Its imaginary part is 2, and so that number lives here. And in fact, Z1 will be this point here on the Argand diagram. Excellent. It's as easy as that. Z2, what's the real part of Z2? It's -2, so it'll be on here. What's its imaginary part? Its imaginary part is -1. Okay, so we come down here, and that is our Z2. Z3, let's have a look at Z3. Well, its real part is root 3, which is approximately 1.8, something like that, so it's around there type thing. And its imaginary part is -2, so this number will approximately be down here, so Z3 down there. Okay, so there's our 3 numbers there. Great, and we talked about in a previous video the modulus, and the modulus is actually the distance from the origin of any point. Okay, so that distance there is the modulus Z. Okay, that's Z1 actually. Wish Eddie would stop crying, it's quite irritating. Here is the modulus of Z1, and it's the distance from the origin. That's what the modulus essentially means. How far is it from the origin? And that's why you get the square root of, just using Pythagoras, 1 squared plus 2 squared is how you calculate that. So that's a bit about the modulus. Just take that off. Excellent. Let's just have a look at what adding together two numbers might mean. So if we do, let's say, Z1 plus Z2, okay, Z1 plus Z2, what does that mean? Let's add these two together. Z1 plus Z2, in fact, can I just do, I'll invent something else, because it's, let's just say this out here will be Z4, and what is Z4? So we'll go back to this. Z4 is equal to, what's the real part? It'll be 3. What's the imaginary part? 1i, so that'll be 3 plus I. What happens if we add these two together? So Z1 plus Z4, if we add those two together, add the real parts together, you get 4. Add the imaginary parts together, I plus 2i, you get plus 3i. So let's just put that on the Argand diagram. 4 plus 3i is 4 plus 3i. So up here you'll get the point Z1 plus Z4. Okay, we've added them together. And what it essentially is when you add together two complex numbers, all you're doing is adding, as if a bit like vectors. We're adding that Z1, and here is our Z4 here. If we add those two together, then we're adding that onto that there, and essentially the answer that we get is like adding two vectors together. We're adding those two together, and our answer is this number here. Okay, so that's what happens. We're adding this complex number Z1 to this complex number here Z4, and the geometric significance, the geometric interpretation of adding two numbers together on the Argand diagram is this green arrow here, which is the adding together. Fantastic. So that's a bit about adding. What about multiplying? Let's get rid of all this. If we're multiplying a number by a number, so let's multiply Z1 by 2. Let's just see what happens. Z2, so let's have a look at Z2. So if we multiply Z1 by 2, let's have a look at Z1 is 1 plus 2i. What's the significance of multiplying by 2? You get 2 plus 4i. Let's plot that on there. 2 plus 4i. So here you'd get 2Z1. So what actually, when you've got this is Z1, what happens when you multiply it by 2? In fact, it doubles its length. Okay, so it's exactly the same direction. It just doubles its length. So if you like, what would 2Z2 look like? Well, this here is Z2. If we double it, it doubles its length, and so Z2 would be down here. So 2Z2. And so that's what the significance of multiplying does. What does the significance of multiplying by a negative number do? So if we've got Z3, what happens if you multiply that by -1? Okay, let's just have a look at that. Z3, let's multiply it by -1. You get -√3 plus 2i. Where does that live on the Argand diagram? Well, we have -√3, which is roughly here, plus 2i, which is up here. So this is where -Z3 lives. So in fact, if you multiply a complex number by a negative number, then it actually reverses it. So there's our Z3. Negative Z3 is actually reverses it. So it sweeps around by 180 degrees around the Argand diagram and becomes negative. What would happen if you multiplied by, let's say, Z1 multiplied by -2? What that would do? Well, the negative will spin it around. So here's Z1 here. The negative will spin it around by 180 degrees, and the 2 will make it twice as long. So it'll come around here, so it would be exactly opposite, and it would be twice as long. So that would be -2Z2 roughly there. So that's the geometric significance of adding and subtracting and multiplying by scalars, and that basically is the Argand diagram. It gets a bit more complicated than that, but we'll sort of cover those in class.